In section 2.5, we're going to start learning how to complete proofs, which are a big part of what we're going to learn in geometry. But to do this, we're going to actually start with proofs that are more algebraic. We're using algebra because it's something that we already know, and it's going to make sense to us when we start learning and looking at how to complete the proofs. So our learning goal is that students will prove statements using algebraic proof. All right, so a proof is an argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. So when we talk about previously proven statements, there's a few things that we're going to be able to use. Obviously definitions, some different properties which we'll talk about in a second, but we're also going to be able to use any postulates that we've already learned, and we're also going to be able to use what we call theorems that we've learned or have already proven. So a theorem is a statement that has been proven. Whereas, remember, a postulate is something that we believe is true, but we can't necessarily prove it. So a theorem is a statement that has been proven. Now, I've got a handout for you here, and I want you to tape this handout in your book now under Properties of Equality. You should be familiar with these properties. They shouldn't seem new to you, but we're going to give them a name. So, for example, the addition property of equality says, if A is equal to B, then A plus C is equal to B plus C. In other words, we can add the same thing to both sides of an equation, and the equation stays equal. We knew that. That's part of how we solve equations, right? And then, of course, the subtraction property of equality says, well, if they're equal, then I can subtract the same thing from both sides of the equation, and it's still equal. The multiplication property of equality says if these two things are equal, then I can multiply both sides of the equation by the same value. And the division property, of course, says that I can divide both things by the same thing. Both sides of an equation by the same value, and they stay equal. So A divided by C is equal to B divided by C, but there is this little catch here. C cannot be equal to 0 because then I would be dividing by 0, totally against the rules. Now this is kind of an interesting property here, the reflexive property of equality, and it says that something is equal to itself. And that seems very strange, but we're going to actually use the reflexive property quite a bit in geometry. A little bit later on. The symmetric property of equality says, well, if A is equal to B, then B is equal to A. It's kind of like we just flipped that equation over this reflection line almost, and we just reversed the order of which thing was on the left side of the equation and which thing was on the right side of the equation. This is an important one, the transitive property of equality. Very important to know the transitive property. It's kind of like the law of syllogisms, but don't let that freak you out. So it says if A is equal to B and B is equal to C, then A must be equal to C. So if these two things are equal and these two things are equal, the first and the third thing had also better be equal. And then the substitution property says if A is equal to B, then B can be substituted in for A in any expression. Sometimes we use the substitution property, like for example when we substitute a value back in to check our work. Now there's one other property that I want to examine with you for a minute, and that's the distributive property. If I'm going to use like variables to describe it, I might say A times the quantity of B plus C. You guys know that that's equal to A times B plus A times C. You can't get through algebra without knowing the distributive property, right? We use it quite a bit. But I want to give you an example of how the distributive property might be used. Let's say I gave you the expression 2x plus 3x. What is that actually equal to? Well, we know we have like terms here. They're both x's. So we add the coefficients 2 plus 3, and 2x plus 3x is, of course, 5x. But why is 2x plus 3x really 5x? What we're really doing here is we're using the distributive property without even recognizing it. This is really like saying x times 2 plus 3. We're using the distributive property in reverse. Do you agree that x times 2 is 2x, and x times 3 is 3x, right? But what we're doing instead now is adding these two terms inside the parentheses, and we're saying, okay, well, this is going to then be x times 2 plus 3 is 5, and then we're writing that in the correct way. X times 5 really should be written as 5x. So anytime you see an example where you're combining like terms, what you're really doing is using the distributive property. You just may not recognize it. Okay, so we're going to do some algebraic proof here. We're going to solve this equation and we're going to justify each step as we go. So when we do this, we're going to start this real formal process already, and we're going to create two columns for ourselves. The left column is going to be statements. Excuse me. And the right column are going to be our reasons. This is how we know we're allowed to make that statement. So in this problem, the very first statement, and this is any problem, the very first statement is the problem that we're going to start with. So we'll number that number 1, and we'll just rewrite the problem. 4m minus 8 equals negative 12. Alright, so that was easy. But the reason here, we're going to say, okay, well that was the problem, and that was the problem that was given to me. So the reason here is given. Alright, now I want you to imagine, what would we do to solve this equation? Well, to isolate the m, the first thing we would do would be to do the opposite of that subtraction, and we would add 8 to both sides, right? But I want you to kind of pretend that that's, well, not even pretend. I don't even really want you to put it in your proof. I'm just putting it in here so you can see what's going on in the solving, right? But if I was doing a proof, my very next statement would be the result of what happened after I added 8 to both sides. So if I add the 8, I would get 4m is equal to negative 12 plus 8 is negative 4. So technically, in a proof, all you want to write is the result of what happens after you do this next step. So the reason that I know 4m is equal to negative 4 is because I added 8 to both sides. I added the same amount to two sides of an equation. That's what we call the addition property of equality. You can write it like that. You can write the addition property of equality if you want to do something like that. That's okay too, but you've got to have that property of equality in there. You can't just write the reason is add. That's not sufficient. Now the next thing that I would do here, you can see, is, well, if I want to isolate m, I would divide both sides by 4. And again, this is something that I don't really want you to write in your proof. I just want you to see it so you can see how we're solving the equation. So I'm going to make it a little bit invisible. Make this guy a little bit invisible because we don't really want him there. We're just understanding the idea. There we go. Oh, he's even more invisible. And now we're going to write the result. So 4m divided by m is, 4m divided by 4 is m. Negative 4 divided by 4 is negative 1. And what did we do to reach that conclusion? Well, we divided both sides by the same amount. So this is going to be the division property of equality. Perfect. And now that's the end of my proof. I've solved my variable and I've justified each step. Let's do another example here, and we won't even put, well, maybe I will still put the work in along the way so you can see what the pieces of the proof are. Alright, so we get our two columns. That's a little crooked, sorry. Statements on the left, reasons on the right. Beautiful. And we'll start with the very first statement. That's so easy. It's just what you started with. 1/2 t equals negative 7. Oh my gosh, this problem couldn't get any easier. Number 1, reason number 1, is given. That was the problem that was given to me. Now if I look at this, all I want to do is get rid of that 1/2. So I can multiply both sides of the equation by 2. And let's just go ahead and skip writing the work there. We'll think in our head what would happen if we multiply both sides by 2. 1/2 times 2 is 1. -7 times 2 is -14. And what did I do to both sides of the equation? I multiplied both sides of the equation by 2. So my reason is the multiplication property of equality. Perfect. Okay, so now let's look at an equation that has a little bit more geometry in it, but it's still going to be an algebraic equation that we're going to do and an algebraic proof that we're going to create. So let's look at this diagram that we have right here. If I was going to solve this problem, I'd say, okay, well, I have a little piece right here, I have a little piece right here, and I have a whole big piece right here, right? So we know from the last chapter or the last unit, whoops, not little plus big. Hello, how about little plus little equals big? That's true with segments, and that's from the segment addition postulate. That's the name for that property that we worked with to help solve equations. So let's find the value of x, and maybe let's find the length of MO so we can complete a proof for this. Okay. Let's start with this, and then we'll justify each step, and the goal is going to be to find the length of MO. Alright, so my very first statement would be this. The length of NO, the whole big thing, is equal to the length of NM plus the length of MO. Remember, these are lengths because there's no little segment on top there. So reason number 1 is not given this time, but I know that that's true from the segment addition postulate. Alright, so now we'll fill in those values. NO was 4x minus 4. NM is, let's see, 2x. And now I'm going to add the length of MO, which is 3x minus 9. Now what did I do here? I filled in the values that I knew they were equal to. I substituted those values. So that is the substitution property. I knew those things were equal, so I substituted those values in. Alright, now the next thing I'm going to do over here, let's look at this side of the equation. I have to combine those like terms. So when I do that, my result will be 4x minus 4 is equal to 2x plus 3x is 5x minus 9. Now remember, we talked about what happens when we combine like terms. That's really the distributive property in disguise. Distributive property. Beautiful. Alright, so now my next step, let's see. I'm going to subtract 4x from both sides because that's going to keep my variables positive. That's going to leave me with a negative 4 on the left. 5x minus 4x is 1x, or just x. And since I subtracted the same thing from both sides of the equation, that's going to be the subtraction property of equality. Please don't abbreviate subtraction with sub, because that could also stand for substitution. So we'll say subtraction property of equality, like that. And now my last step, let's see, I'll add 9 to both sides, because I have a subtraction here, so we'll add. That's doing the opposite. Negative 4 plus 9 is 5, and that's equal to x. And so that's the addition property of equality. Beautiful. Now let's go one step further and say that, not L, sorry, MO we knew was equal to 3x minus 9. So if I plug in that value, I'd have 3 times 5 minus 9. So still in that statement, 15 minus 9 is 6. So the length of MO is equal to 6. And again, that would be substitution because we substituted that value of x into the entire length of MO. All right, so let's do one more where we just, let's just solve for x and then we'll write a justification for each step in a similar way that we did last time. So we'll have our statements and our reasons where we provide ourselves a justification. All right, first of all, with angles, we also know that little plus little equals big, but this time that's the angle addition postulate. Little angle equals big angle. So here, my first step is going to be to say the measure of angle ABD. Okay, look at which angle that is. ABD. That's this guy. Plus the measure of angle DBC. Okay, DBC, that's this guy. Little plus little is going to equal the measure of the whole big angle ABC. I didn't really quite leave myself enough room. And that would be the angle addition postulate. Beautiful. All right, so now let's plug in those values. We'd say 3x plus 5 plus 6x minus 16, oh, I really wish I had more room here, is equal to the whole big angle, which is 8x. All right, so that's substitution because we substituted those values in. All right, so now in my equation here, I'm going to combine these like terms and I'm going to combine my constants. So my next step will be to say, all right, 3x plus 6x is 9x. 5 minus 16 is going to be negative 11, and that's going to equal 8x. So remember, that was the distributive property. Beautiful. And now my next statement. Normally I would move the 8x, but since I only have one constant over here, I'm going to go ahead and subtract 9x from both sides. And I'll say that means negative 11 is equal to 8x minus 9x is negative 1x, or negative x. I subtracted 9x from both sides, so that's the subtraction property of equality. Beautiful. We're almost done. If I really want to get what positive x is here, I could divide both sides by negative 1. And negative 11 divided by negative 1 is positive 11. Negative x divided by negative 1 is positive x. And so that would be the division property of equality. Now if I wanted to, I could even go one more step forward, which you don't have to do. But then you could make the statement that x is equal to 11. If 11 is equal to x, then x is equal to 11. And remember, that was the symmetric property of equality. Sorry, there we go. Symmetric property of equality. And that's how we could justify each step. That's algebraic, but still looking at how geometry might play into it as well. All right, so that's it for the notes. I want you to do your summaries, put in your left-hand column questions. Make sure you get those properties taped in the right spot and neatly. And then there will be another short little homework quiz at the beginning of tomorrow.